Good morning. This is Haseeb from the SkipQ batch. This is our first week problems, and we are trying to solve two LeetCode problems. So this is the first problem we are given. So here we can see we have third maximum number. So the third mean tisra, right? Third and maximum mean the highest number and the number. So given integer array, so we are given with the integer array, right? We are given with this integer array. If I try to annotate the screen, give me a second here. Yeah. So we are given with the okay, let me choose the marker here. We can see we are given an integer array nums. So this is the array we are given. I hope you guys can see my screen clearly. Okay, so we are given this array. Return the third distinct maximum number in the array. So what the third distinct exactly mean? So in order to understand the third distinct, let's try to understand what exactly the maximum is, and the second maximum, the third distinct maximum. So this is this is the color. I will select this one. This is the box, right? This is the L1 largest box, right? This is the largest box. And what do you call this one? This is the L2 second largest box. And what do you call this one? This is called L3 third largest box. So basically if I put 3 here, this is the this is the largest number, right? And this is the second largest number compared to 3, and this is the third largest number compared to 3. So this is how the approach goes. So in this case we have 1 here, so 1 is the third largest number. So we are given but there the condition is clearly mentioned. This should be a distinct maximum, third distinct maximum. So what exactly the distinct term means? So let me try to explain the third distinct concept, what exactly the third distinct mean, and after that we will move on to the next part. So the third, I was here to explain third distance, right? So this is the array we are given. Suppose 3 5 5 2 1. So how do you find the third distinct number here? Okay, so the first approach is to remove the duplicated values like 5 5. So here we can see 5 5 is duplicated. Just remove that here. Okay, so just remove the 5 5 from here, and now we left with 2 and 1. Okay, we can't still figure out third largest number because we don't know the largest number. Oh, for us it's easy. This is the 5 largest number, this is the second, and this is the third. But in order to make sense out of it, we will just sort this in descending order. We will get this 5 3 2 and 1. Okay, so if you can see here, this is the largest number, this is second, and this is third largest number. So we will return 2 in this case. Now it makes sense, I hope so. This thing is now making a clear sense to you guys. And if the third maximum doesn't exist, so if the third one doesn't exist, if there is third one doesn't exist, in that case we will just return the maximum, which is 3, the third, sorry, which is 3 here. So we'll return this. So if we have 4 2, in this case we have first largest number, second largest number, we don't have third largest number. In this case I will just return the 4. If the array is sorted, right, if the array is sorted, if the array is sorted 3 2 1, then we have this third largest number. Okay, if we don't have this, we still need to sort the array, and in this case I will turn the zero index, which is third, because we are already in descending order. In descending order we have largest first, sorry for mistake, largest first, and then at the end we have smallest. So if there is no third largest, we will return the largest, which is located at the first position, zero index. I hope so this makes sense to you guys. So without wasting any time, I guess we should jump into the coding and see how it should progress. Yeah. So the first thing is to make sure that we have array inserted. Oh, before sorting the array, okay, so let's sort the array, and after that we will try to analyze the time complexity during implementation. Yeah, so the pseudocode I will write here for you guys is the following one, and you should stick to this pseudocode, right? So sort numbers. So first step our is to sort the numbers, right? In order to sort the numbers, we will just write a function self dot quicksort. So I am using a quicksort algorithm. I will pass nums to it, and it will return nums for me, which will be a sorted, right? So I will define ef quicksort. I will pass self nums, and that's it. And it will take, we have a base case inside a quicksort. Yeah, it has a base case. In base case we will say if length of num is less than 2. In this case we have one element inside array, so just return nums. Oh, this is nums. So this is our base case, and then we have some kind of condition inside the quicksort. And quicksort is also a recursion technique, right? Else what we gonna do is assign a base, which is a pivot, and inside pivot I will nums of 0. The 0 first index will be our pivot, and then we will define a less, so we will call it greater, and I will push the element greater to the left to the pivot, and middle we will have a pivot, and to the right we have less, and similar the pattern continues, and we will get the sorting array. So greater is equal to number for number, let's call this number for number in for number in nums, right? If number is, so me trying to make shift the greater value to the left, so it will be a less than or equal to a pivot, right, to the pivot, and we'll define less, and same goes with the less. But in case of less, we are trying to make sure that we push the less element, the element which are less in numbers, to the right side. So in this case the condition will be like this: if number is greater than pivot. Okay, let's try to make sense out of it. If number is less than pivot, it should be attached to a greater, right? Let's try to make sense out of it. No, so this will doesn't work, because we are trying to shift the lesser element. So if what's going on here. Let's try to make sense out of this thing. Okay, so there is a less one and we are passing a less one here because we are moving less to the right, and we have greater here, greater, we are passing greater here. This sign means greater, and this is also representing greater, and this sign represents less, and this is also a less. Let's go. That's cool. So let's try to do extra. So now after sorting the element, we need to make sure we get that unique element because we are mentioned third distinct maximum. For this purpose, I will just implement nums is equal to set and pass the nums and print the num. Oh, so that set doesn't make sense because sets contain unique element, but it changed the order. So for that, what I can do is try to make a new list and insert those element uh, inside unique element side list. So I will call new list, and I will loop through for I in nums if I not in new list, just append that new list, append the item to new list. So append I to it. Right, if item doesn't exist in the new list, just append. If in case it exists, we will leave it, as it. So now if I print the new list here, we are getting 4 3 2 1. Now if length is less than 2, that convey that I have no third distant max element. So in this case I can just return new list, the 0 index one. So the 0 index will contain the maximum element. Yeah. Also the better approach will be like if it's greater than 2 length, so we should return the third, else just return the max return the max value. Yeah, we can do that. So I will just return the new list 0. I just try to run this. We are good here and try to submit this with cases. It is submitted. Now let's discuss time complexity. Okay, so start from the here. This is our main function call, right? So this will take off one. No, sorry, this will not take off one. This will call this function, and this function will take of n, which is quicksort. Quicksort has a big of time complexity of n, and this for loop, this one will take again of n, and the rest is constant time, those are of 1, I can say. So now if I total sum of this, so I am getting of 1 plus 2 times of n. Just ignore this, we getting 2 of big of n, and ignore this as well. So we are left with time complexity, let me write it here. So we are left with time complexity of big of n. Yeah, so that's it. What are the limitations, some edge cases to the problem? The problem is this: in case the list is already sorted, so that will cost us a lot more time, because the quick sort, if it's sorted, let's say this list item is 3 2 1 minus 1 2 minus 2, sorry, and so on. So in this case it will give us a little more time, so that will cause us input to be slow, so it will cause us slow, yeah, it will be give us a slow runtime. So that's it for this question. I guess let's deal with another question and see what we can get out of it.